Alright, this is video number 2 in our similarity unit. We're talking about angle, angle, side, 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 and side, angle, side, triangle, similarity, okay? And so your learning target is I can prove and solve problems of similar triangles using AA, SSS, and SAS. So in order to prove and solve problems of similar triangles, remember yesterday we talked about how similar triangles had to have all congruent angles and all proportional sides in order to prove the two triangles are similar. Now what these do, there's these three shortcuts really, AA, SSS, and SAS. What they do is that they prove the triangles are similar without having to prove all angles are congruent and all sides are proportional. Okay, so in order to do that, first thing we need to do is identify what shortcut, is it AA, SSS, or SAS, that we could use in order to show the triangles are similar. And then the second step is to prove the corresponding angles are congruent. You got to use those ones that you need in order to use the shortcut you identified in step 1. And then also prove that the corresponding sides are proportional that are needed to use the shortcut identified in step 1. Okay. Now we have this postulate here. And postulates mean that we just know it's true. That's what a postulate is. And it says that angle-angle similarity, if we have two angles of one triangle that is congruent to two angles of another triangle, then the two triangles have to be similar. So if you have two angles in two different triangles that are congruent, the two triangles, they have to be similar. So example 1 tells us to explain why the triangles are similar and then write a similarity statement, okay? So the first thing we can see here, based on looking at these two triangles, is that this angle BAC and EDC are going to be similar. Or they are going to be congruent, sorry. Angle BAC is congruent to angle EDC. And we can see that because that's they're both right angles. Okay, they're both right angles, so we know that those are going to be congruent. And we can also see here that these two angles are vertical angles. Angle BCA and angle ECD are also going to be congruent. Okay, so angle BCA is congruent to angle ECD. And that's because those are vertical angles. Okay, so now that we've proven that those two are congruent, that those two triangles are congruent, or sorry, those two angles are congruent, then we can say that the two triangles are going to be congruent. The triangle ABC is similar then to triangle DEC by AA. That is writing a similarity statement. We're saying here that these two triangles have to be similar because we have these two angles that are congruent. Okay, let's do some more theorems. So theorems are a little bit different than postulates. Theorems are proven. It's been proven that this is true. Okay, so if you have side, side, side similarity, that's another one of our shortcuts. It says that if three sides of a triangle are proportional, three sides of a triangle are proportional to three corresponding sides of another triangle, then the two triangles are similar. So if you have corresponding sides and they are all proportional to one another, meaning they have the same rate or same ratios of sides, that means that those two triangles are similar. Okay, and then there's another one, it's the side angle side similarity. That says that if two sides of a triangle are proportional to two corresponding sides of another triangle, and the angle formed by those two sides are congruent, then the triangle is similar. So what that means here is that, like for this example here, AB and DE are proportional to BC and EF, and the angle formed by those two lines, so at angle B and angle E here, if those are congruent and those are proportional, then the triangles are similar. So for example 2 here, we're supposed to verify that the triangles are similar. And we can see here we've got some sides, another angle, and another side that is given to us. So we're going to try to prove these two triangles are similar based on side, angle, side, because the two sides, we know two sides and an angle that is formed by those two sides. Okay. So this first side that we can see, the two corresponding parts of that is line DE and line HJ. Those are the corresponding sides. For the angle, that's angle D and angle H. And they should be equal to each other for them to be similar. And the last side is DF and HK. So what this says here is that in order to prove these two triangles are similar, these two, D and H, have to be the same. They have to be equal. They have to be congruent. And then these two side ratios have to be proportional, or they have to be the same ratio. Okay, so let's go ahead and first do the angles. We've got angle D and angle H. We can see angle D is 70 degrees. And that needs to be equal to angle H, which is also 70 degrees. And so because those are congruent, we've got our angle. That's the good piece of information there. Now the sides, we have DE, side length DE is 2 over side length HJ is 1. And if we go over to DF, DF is 5.8. And HK is 2.9. Which if we reduce this ratio, which we can reduce it, if we divide 2.9 by itself, we'll get a 1 in the denominator, and 5.8 divided by 2.9 is actually 2. And so because these ratios are the same, that means those two sides are proportional. So we have two triangles that are similar. We can say triangle DEF is similar. Remember, that's the symbol for similar. To triangle HJK by SAS. Alright, our last example here, we need to verify that the triangles are similar, and we can see in these two triangles we do not have any, there is absolutely no angles that are known. So what we have to be using, we know all the sides, so we're going to be using SSS. SSS Triangle Similarity, and so we got to see if these sides are proportional in order to actually state that the triangles are going to be similar. That's what the SSS side theorem says. Okay, so let's take a look at our corresponding parts. We've got line PR, that's going to be corresponding to line SU. PQ is going to be corresponding to UT. And finally, RQ is going to be corresponding to ST. Okay, and if we write out all of these ratios here, if they're all the same once you get it into its most basic form, then we will have proportional sides, right? So PR is 2. And SU is 3, so our ratio is 2 to 3. Okay, PQ is 3, and UT is 4.5, and we see that RQ over ST is the exact same. This is an isosceles triangle. We can see that because these sides are the same. Okay, now 3 and 4.5, it has one number that's kind of in common here, that both go into 3 and 4.5, and that's the number 1.5. 1.5 times 2 is 3, and 1.5 times 3 is 4.5. And so we can actually reduce this down to 2 over 3. Both of these can be over 2 over 3. And so because all of these ratios are the same, because 2/3 is the same for every single one of these sides, those ratios of the corresponding parts, that means that these two triangles have to be similar because they have proportional sides. So triangle PQR is similar to triangle STU by SSS. Alright, that's it. Hope you enjoyed.